Lesson 4.1, Translations. The essential question, how can you translate a figure in a coordinate plane? All right, let's take a look at vectors. We are going to use some terminology that's a little bit more sophisticated than slide that was used in the lower grades. We're going to use vector to tell us how we're going to move a figure. And a vector has an initial point P and a terminal point Q. The vector is read vector PQ. The symbol for the vector is, we start with P, the initial, to Q, and it is kind of a half arrow so that it's not going to be confused with a ray. We have a horizontal portion and a vertical portion to tell us how to move the figure. In component form, it looks like this. And notice that we're not using a parentheses, but this kind of a symbol here that will tell us it's a vector and not a point. Okay, in this diagram we're going to name the vector. And again, the initial point is J, the terminal point is K, and then we do this half vector. That is the name of the vector. Its component form, we can see 1, 2, 3. The horizontal movement is +3. And 1, 2, 3, 4, the vertical movement is +4. Okay, translations. What do translations mean mathematically? Mathematically, we are going to move the same distance, all points the same distance and the same direction. But that's not mathematical. That's just describing it. Mathematically, what's happening is the distance from the initial to the end, from the initial point to the end point of each one of the points that are being moved, they're going to be equal in distance. That's what we mean by same distance. That from the beginning to the end, that distance is the same as from the beginning to the end of any other point. And this is most important, direction. Okay, how do we describe direction? We describe direction with parallel. So if we're going to move in the same direction, it means that these points are going to be moving parallel to each other. All right, let's go ahead and translate. I'm going to start with point A, which is 0, 3. This is point A. B is 2, 4. And C is 1, 0. All right, now what we want to do is we want to use this vector and translate it. So I'm going to take the point A, 0, 3, and I want to move it over 5 units and then go down 1 unit. So I'm going to move it over 5 units, 1, 2, 3, 4, 5, and then down 1. And that's my point A, prime. And we use A prime to show that it's moved. So this is going to be the point 5, 2. Or I'm going to do the same thing with B. I'm going to move over 5 units, 1, 2, 3, 4, 5, and down 1. So the point B, which was at 2, 4, is now going to be B prime, which is going to be 7. And instead of 4, it's going to be a 3. So that's B prime. And now C, I'm going to move over 5 units, 1, 2, 3, 4, 5, and then down 1. That's going to be C prime. So C is 1, 0, and C prime will be 6, -1. Now let's go ahead and draw the lines here, and you can see that it satisfies the definition that we just talked about. And the fact is that each point is going to move the same distance. Let me see if I can undo that. It's moved the same distance. So all of these distances, A prime, will be equal to B prime, which will equal to C prime, and they will all be parallel to each other as well, and that creates the same direction. Okay, let's write a rule for the translation from triangle ABC, which is called the pre-image, to the final, which is the image. Now I'm going to draw my vector, and let me do it in black here. And I'm going to do it with any one of the points A to A prime, B to B prime, or I'm going to do it to C prime. And there's my vector. And notice that I'm going back 4 units and I'm going up 1. So this vector is going to be -4, 1. Now they're not asking me to write the vector, they're asking me to write the rule. So let's talk about how we write a rule. And the rule will be written this way. This is the way the point starts, and we're going to map it, that's a mapping symbol, to, we're going to take our x values and we're going to subtract 4, and then we're going to take all our y values and we're going to add 1 to them. So this is what we're going to do to each x and to each y, and that's what we call writing a rule for a translation. Okay, let's notice that they're giving us the rule right here. They're telling us what to do with the points. I have graphed the points already. They're over here and they're ready for me to figure out what their new location is. So A prime is going to be -1, and then I'm going to add 3 to my x coordinate, comma, I'm going to have 2, and then I'm going to subtract 1 to my y coordinate because that's what the rule says. And so my A prime will be 2, 1. So now A will be 2, 1 right here. That'll be my A prime. Okay, and then to figure out my B prime, I'm going to do the same thing. B prime, I'm going to take -1. I'm going to add 3 to it, comma, and then 5, and then I'm going to take away 1. So my B prime will be 2, 4. So I'm going to go over here, and my B will be 2, and then up 4 here. So this will be my B prime right here. All right, and let's see if we can do the rest in our head. C prime will be, I'm going to take the number 4 and add 3 to it, so that's going to be 7. Take the number 6, subtract 1, and that's going to be 5. So I'm going to go over 7 and up 5. 1, 2, 3, 4, 5. That's going to be my C prime. My D prime is going to be, I'm going to use my rule, add 3 to my x, which is 7, and then subtract 1 to my y, which is 1. So I'm going to go over here to 7 and go up 1 right here, and that's my D prime. And then I'm going to go ahead and make my lines. And again, you can see this translating idea. And again, the definition is that B to B prime will be the same length as C to C prime, A to A prime, D to D prime, and direction means that all of these will be parallel to each other. Okay, go ahead and try this on your own. Stop the screencast and then I'll show you the answer. And here's the answer. Okay, here's a problem that I've done all the way through. It's asking me to use this rule. Notice that each time I would add 1 to the x, add 2 to the y, and I got my new image. This is the pre-image, this is the image. Take a look at the original triangle, take a look at the translation. Okay, here's our postulate. A translation is rigid motion, which means the shape really never got bigger or smaller. It just stayed the same shape and size. That's what rigid motion is. The composition of 2 or more rigid motions is a rigid motion. Let's take a look at this situation. What we're going to do is we're going to take each point, R and S, and we're going to move it twice. So let's take a look at how I go about doing this. I'm going to take the point R, which is -8, 5, and I'm going to translate it. This first translation will be r prime, and I'm going to add 5 to it, which is minus 3. So that will be negative 8 plus 5, and then I'm going to take the 5 and subtract 2, so that'll be 3. So I've done this first translation. Now I'm going to take this point and I'm going to translate it to here. So this will be r double prime, which means I've gone through a second translation. I'm going to take negative 3 and subtract 4, that'll be a negative 7, and take the number 3 and subtract 2, and that'll be a 1. I'm going to do the same thing with s. It'll be negative 6, 8, s prime. I'm going to add 5 to my x, that'll be negative 1. I'm going to subtract 2 from my y, that'll be 6. So that's my first translation. Now I'm going to go to this next translation. I'm going to take the negative 1, subtract 4, that's negative 5. And then I'm going to take the y value here and subtract 2, and that'll be a 4. So let's go ahead and plot these. The original points were negative 8, 5, which was r, and then s, which is negative 6, positive 8, negative 6, positive 8, which is s right here. Okay, now let's go ahead and plot the final points. Negative 7, 1, which is r double prime, and then negative 5, 4, which is s prime. And I want you to notice that the graph looks like it's rigid motion. The lengths look like they're still the same. And notice that we followed the same idea of the same distances from r to r double prime, s to s double prime, and the parallel nature. Okay, here are 2 other examples that I've worked all the way through. I'm trying to show you that each time I used the rule, found that point. Once I found that point, I used the next rule to find them. And I did this with point T and point U. And again, I showed the graphs to show how they translated. And here's one more example. Again, you have to be very careful about doing your arithmetic correctly and adding and subtracting correctly to get your values. And if you do that right, you'll see that translation motion.